everyone. Good morning, good morning, good morning. Hello, hello, hello. Right. Sorry for delay. So my voice is audible. Please confirm once on a comment chat box so that we can, start our session for today. And very good morning to everyone. Today is gonna be our first class on engineering mathematics. Uh, and please confirm my voice is audible properly. Yeah, perfect. My voice is audible and everything is perfect. So we will be taking care of the subject called engineering mathematics. Okay, from April 1, and yeah, so everybody has to attend the session in the morning. Okay, on this YouTube channel where the link will be shared. Yes. Okay, so we will be starting with the mathematics. Okay, and why mathematics is important. So in couple of hours you will be understanding, right? Because mathematics plays an important role, okay, in order to understand all other technical subjects. So hi Devans, Ganeshka, Shivam, Saurav. Okay, so there are many students. Okay, so you guys can just you don't have to share this link anywhere, just you have to watch it right carefully. So let me begin directly. Okay, so I will be starting with the syllabus of gate 2024. Okay, so you can just take a look on the syllabus. Okay, for all the branches, for electrical engineering, for instrumentation, as well as for, right. So let me show you the syllabus directly. Okay, so this is our first class. Okay, the class for, you can say, GCA 1, GCA lecture number 1, right. And the syllabus for ECE we have got here. Okay, the syllabus for ECE is this. I hope you might be able to see the screen now. So the syllabus for ECE is basically we have got the linear algebra. The very first chapter is linear algebra, okay, where the vector space, the basis, linear dependence and independence, matrices, eigenvalues and eigenvector, rank, solution of linear equation, existence and uniqueness, right? And the second topic is calculus. The third topic is differential equation and the vector analysis and complex analysis and probability and stats, right? So earlier transform theory was also the part of GATE syllabus, but now they have removed from ECE syllabus, right? But it plays an important role in signal and system. Okay, so yeah, good morning, Rajiv, right? So these are the syllabus. Okay, we have got how many topics are there? One, two, three, four, five, six. Okay, so primarily today's session will be on linear algebra, and you will understand that why we are talking about linear algebra. What is the main objective of discussing linear algebra, right? And you have to also find the intersection of these topic with your core topics, okay, with your technical subject, right? So linear algebra is very very important, okay, where we will be discussing the geometrical meaning of linear algebra. Okay, you can see here the vector space. What is the meaning of vector space? You know, and what is the difference between the vector and the eigenvector, right? We have got eigenvector, we have got eigenvalues, right? So what is the difference between eigenvector and the eigenvalues? Okay, and also we will see here what is the meaning of linear dependence and independence. There are other topics as well, I will be listing down, okay, once we will start linear algebra. Okay, so if I talk about the intersection of these topic with your subject, so there are eight, 8 to 9 subject, right? We have got, like, we start with network theory, okay, then control system, digital circuit, okay, and devices, analog, signal and system. There are many subject, right? Everywhere you will find some concept of matrices will be there, right? Like if I talk about signal and system, and if you belong from electronics and communication, so there will be the DFT, okay, discrete Fourier transform. Okay, so you will find there also one matrices we use, right? And in fact circular convolution also can be performed using those matrices, right? So everywhere, if I talk about control system, so one chapter is this state space analysis. Okay, there we use again matrices, right? When we talk about state transition matrix and all, right? So everywhere the concept of matrices, concept of linear algebra will be there. And if you want to solve the system of linear equation, right? If you have got two, three equations and you have to solve it, okay? So it's okay if I give you two equations and two unknowns, you can easily solve the system of linear equation. But if I give you five equation and five unknowns, right? How can you solve them? Okay, suppose if you have been given a network and you have got six loops, okay, and you have to solve the equation, right? You have to find the current in each loop, okay. Then you have to use the concept of linear algebra, right? Okay, so these are the concept. This is the syllabus for ECE, and from this syllabus, linear algebra will be asked for 5 marks, 100%. Okay, and calculus, differential equation, vector analysis. So if you are good at linear algebra, calculus, and probability and statistics, okay, so all other chapter will be very easy. For for electrical engineering, this is for electrical engineering, okay, the matrix algebra, system of linear equation. So you see here the syllabus is very tiny, right, compared to electronics. They did not mention about vector space, okay, they did not mention about anything, but you have to study everything, right, because they have just mentioned your class 12 syllabus. Next, electrical engineering, instrumentation one. So these three branches we are going to cover for in today's session. Though all the branch of engineering has got same syllabus, right? So these are the syllabus, right? Okay. So let me start with the linear algebra directly. Okay. So linear algebra. And I will be mentioning the topics, what topics you have to study. Okay, so you have to make the note. I will be also sharing the PDF after the session. Okay, and this session will be recorded as well, so you guys can watch any number of times in your free time. Okay, so see, the very first topic I will be discussing here is the under linear algebra will be what? The objective of linear algebra. Okay, objective. What is the objective of linear algebra? Why we are talking about linear algebra? What is the meaning of that? Can somebody tell me what is the main objective of discussing linear algebra? In the chat box, you guys can write what is the need of linear algebra? Why we talk about linear algebra? So you guys can tell me. Second one will be the to discuss linear algebra, okay, we need some tool. Okay, so that tool will be the matrix and determinant. Okay, so we will be talking about matrix algebra here. Matrix algebra, right? The third will be, this is just a tool, okay, and the third will be determinant. Okay, yes. Yes, Shivam, to solve system of linear equation. Yes. Okay. If you want to solve the system of linear equation, the linear algebra is there for you always. He says that, yes, give me m number of equation and n number of unknowns. Okay, I can solve in like this. Okay, and there are some procedure. Okay, how to solve, right? I will be discussing them. The question of elimination, right? The powerful tool we will be discussing, the elimination, which you have seen in your class 10th also, जो आप क्लास 10th में देख चुके हो, राइट? एलिमिनेशन कैसे परफॉर्म करते हैं, आज के सेशन में आपको सब कुछ क्लियर हो जाएगा, ठीक है? और आपको ये भी याद रखना है कि रोम वॉज नॉट बिल्ट इन अ डे. We don't have to complete anything in one day. We have to take some time. Okay, so we will be investing. Yes, Devans. Solution to equation using matrices. Yes, you can say matrices, perfect. Okay, and without matrices also you can solve if you have got two equations and two unknown. So basically you have to tell solution to solve the central objective of linear algebra is to solve system of linear equation. That's it. Okay. The determinant, and then we will talk about concept of vectors, right? The concept of orthogonality. So many things will be there. Okay. Okay, so I think I have also shared some of the points, okay, like what we are supposed to discuss under linear algebra, okay. So, yeah, so determinant, then we will be talking about system of linear equation, okay, system of linear equation, okay. Hmm? And the fifth one is going to be the norms of a vector. You know, concept of vector we will discuss here. Concept of vectors. Of vectors. Okay, we will not get into detail of those kind of a vector. We are going to talk about row vector, column vector. Okay, and here we will discuss the properties of vector, right? Like orthogonality, orthogonal, how two vectors are orthogonal and all, orthonormal, right? Here we will talk about orthogonality and orthonormal, concept of orthonormal, and I will prove also, right? And norms of a vector, norms of vectors, okay. What is the norms of a vector, okay? Why we talk about norm? What is the meaning of norm? So can somebody tell me what is the meaning of norm? What is the meaning of norm? Yes. Uh, so norm is basically, to measure the size of the vector. If you want to know the size of the vector, suppose I give you one vector here, this is a vector. So if you want to find the norms of a vector, right? So what is the size of the vector? Okay, you can say, suppose this vector is of length 5, right? This vector is of length 5, so you can say norm is going to be 5. So norm is nothing but a size of the vector, that's it, okay? How, uh, you know, what is the size of this vector is that norms is gonna be giving you, right? So ये 6 number topic है that you have to keep in mind, ठीक है? And then we will talk about already we have seen here concept of orthogonality and orthogonal. Next, the seventh topic will be here the concept of vector space and subspace. Vector space and subspace. Okay, so vector space and subspace will be the topic of discussion, and it is very very important. What is the meaning of vector space? Okay, so if I give you bunch of vectors, suppose I give you 4 to 5 vectors, what kind of operation you can perform on the vector? Okay, suppose I give you 2 3 numbers, in fact forget about vector, right? I give you 1 2 3 4 5 6 7 8 9 10. What you can do with these numbers in general? Can you tell me what you can do with these numbers? See, if I give you any number like 1 2 3 4 5 6, right, you can add those numbers, right? You can add those numbers, okay, like 1 plus 2 plus 3, like that, okay. So in the same manner, if I give you two vectors, so what you can do, you can add two vectors, okay, or you can also multiply some scalar constant with the vector to increase the length of a vector, right? What will happen? They go. Suppose this is a vector, right? And this vector has got, suppose this is 2, the length is 2 here, right? The vector has got 2 length. And if you're going to multiply by some scalar constant, right, 3, just multiply by 3, what will happen? Does the direction of the vector change if you're going to multiply by some constant? Tell me. Your direction of the vector will not change, okay? Your direction of the vector will not change, right? Keep in mind this, okay? Direction of the vector will not change, only the length of the vector is going to be changed, right? So with the vector you can perform couple of operations, okay? you can add vectors, you can multiply by the scalar, right? So these are some properties of the vector space which we will see. Okay, so vector space is nothing but a plane. Okay, space is nothing but a plane, right? We will talk about two-dimensional plane, three-dimensional plane. Okay, uh, perfect. So vector space and subspace, and topic number 8 is going to be, topic number 8 will be what? The concept of linear combination of vectors. Okay, what is the meaning of linear combination of the vector of vectors? If you understand the linear combination of vector, then one of the very important topic will be that is the span. Okay, you will be able to understand what is the meaning of span, right? So linear span and spanning set. Okay, because next year ISC Bangalore will be conducting the gate examination, so they will be 100%, they will be focusing on linear algebra. Okay, because of AI and data science, machine learning. So I will be giving you the objective also why we are studying linear algebra, not only to solve system of linear equation, but there are various application. Okay, so today is the first session, so you have to uh, you know uh, come to know about all these things. Okay, so then we will talk about linear dependence and independence. Okay, the concept of Li and Ld, the definition and the meaning. What is the meaning of linear independence and linear dependence? Okay, the 11th topic is going to be, see, once you know the spanning set. Okay, spanning set is nothing but generating set. Okay, spanning set is nothing but generating set. And once you know the generating set and the concept of linear independence and dependence, okay, so what you will do here is, suppose this is the set. Okay, that is the spanning set, right? And suppose this is the combination of vectors which are linearly independent. So the intersection will be known as the basis. Okay, the basis. Okay, the basis will be the set of vector. Okay, basis is going to be set of vector which are spanning the space as well as they are linearly independent, right? So we will talk about the concept of basis and dimension. Okay, I hope everybody understand what is the meaning of basis and dimension. Okay, so guys, you might be noticing now, Dheeraj sir, why you not discussing about matrix? Why you not discussing about determinant? Guys, those are the tools. Okay, remember always. Already you have studied those things in your class 12th, but I will be giving you the recap. Okay, I will revise those concepts, that's it. Okay, so that you should not face problem. If I will spend 20 hours on just explaining you what is the order of the matrix, what is the meaning of the matrix, then in the gate examination you will not be able to solve any question. I have to explain you the concept, right? So these are the concepts which should be covered in the classroom. Nobody discuss these concepts. Okay, so 11th topic is basis and the dimension, and then we will talk about the very important concept is eigenvalue and eigenvector, right? Eigenvalue and eigenvector. So I will also ask that what is the difference between a simple vector and the eigenvector. So can somebody write in the chat box the what do you understand by eigenvectors? Okay, how it differs from the simple vector. Okay, suppose I give you two vectors, okay, and one matrix is also, right, one matrix. How can you determine that, yeah, this vector is the eigenvector, this vector is eigenvector, and this vector is not the eigenvector, right? You should be able to tell. Shivam Kushwaha, you don't have to refer any book as such. My lecture will be itself a book, but I will suggest you, once the complete, lecture will be finished, so I will suggest you some of the material, right? But for the moment, you have to follow next 15 hours, so that you will become, you know, what you can say, you will become master in linear algebra, right? Only you have to refer PYQ, okay, the previous year question paper, and whatever question I am going to share with you, right, those questions you have to solve. So eigenvalues and eigenvectors, okay, this is very very important topic, mm, okay, this topic is very very important, that's why I'm highlighting. Okay, and also these are very important, or like basis and dimension. Okay, the dimension and the basis. Okay, basis is nothing but a set of vectors, dimension is the number. Okay, it is just a number. Okay, number of vectors which are present in the basis. Okay, next, 13 topic, the number 13, right, the topic number 13 is going to be the concept of algebraic multiplicity. Okay, concept of am and gm, right, am and gm. What is the meaning of am, algebraic multiplicity? Algebraic multiplicity. And what is the meaning of this? uh, Geometric multiplicity. Okay, the gm is nothing but geometric multiplicity. Okay, why we are discussing about am and gm, that you will understand. Okay, uh, if you know the concept of am and gm, so you can clearly tell how many number of linearly independent eigenvectors are there. You can calculate the number of linearly independent eigenvectors. Okay, number of linearly independent eigenvectors, right? So linearly independent eigenvectors. Okay, so if you want to calculate linearly li of, okay, linearly independent, number of linearly independent eigen vectors. Okay, if you know the concept of algebraic multiplicity and geometric multiplicity, and this was the topic asked by ISC Bangalore. Okay, in I believe in 2016, right? So this is very important topic. Next year this question can be asked. Okay, they will give you the matrix A and they will ask you how many linearly independent eigenvectors are there. So you have to calculate. So if you know the concept of AM and GM, okay, if you know how to describe eigenvalue and eigenvector algebraically and geometrically, okay, what is the meaning of geometrically? Okay, with the help of vector interpretation. Okay, I will show you in a while. And then we will discuss the 15th topic is the concept of similar matrices. Okay, concept of similar matrices, and this topic was asked from my notes, okay, this year in gate 2023, concept of similar matrices. Next, 16 topic is diagonalization. Okay, diagonalization. What is the meaning of diagonalization, when matrix is going to be diagonalizable and all, right? And the 17th topic is Cayley-Hamilton theorem. Cayley-Hamilton. Okay, and your 18, the last topic is going to be the LU decomposition. Okay. So I believe these topics are like you can see these topics are not given. Hi Tanisk, yes. These topics are not given in our syllabus, right? Okay. So this is the broader picture of the going to be. Okay. This is broader picture. I hope you guys might have noted down. I can also give you the time to note down. Okay. So the vector space. So I think you might not have covered these topics. Okay, in your BTAC, neither in anywhere wherever you might have been attending sessions. Right, you might be preparing for GATE. So these are the topics I think many of you might not have covered. Right. So now you will be getting a chance to cover. Okay, so in my session you will also come to know that what is the difference between these top like eigenvalue and eigenvector. Any value is there are many kind of values, right? But why that is known as eigenvalue and eigenvectors, in signal and system you will hear the word eigenfunction. Okay, there will be some set of specific input if you will give to the system. Okay, so that the same input will be given, like you will get the same output. Okay, provided there will be some scalar multiplication, right? That will be the eigenvalue. So we have got many application, okay, of all these topics in our technical subject. Now the question is, why linear algebra? Okay, why linear algebra? Now I welcome your thought. Okay, so the very first, what is the main, like why linear algebra? The very first is what? Very first is to solve system of linear equation. Okay, if you want to solve the system of linear equation, the linear algebra should be there for you. Okay, so if you want, okay guys, this is very important to remember. To solve system of linear equation, okay, to solve system of linear equation you need linear algebra. Understood everybody? And what other application you can tell me? Tell me fast. What other application you can just tell me? So there are various applications which I will be mentioning here, right? So you can say here the very first is the data science and the machine learning, right? Data science. The second one is electrical network. And the third one is, you can say, if I talk about uh, cryptography, right? There are various applications like cryptography. Okay. Fourth one is like graph theory. In this year in computer science, one of the question was there from this, like you have to find the eigenvalues, and there was some state transition diagram. Okay, so you have to determine. So many students got confused as well. So and there are many, in different domain. Okay, wherever the data is available, so much data is available, you have to deal with the data. So you can go for this, right? We can talk about genetics, okay, and many more. You guys can also tell me what are the application from this. Yes, so many topics are there, right? So please increase your, and also let me tell you very proudly here, right? I'm taking AI, right? I'm taking AI from ISC if you want to pursue, right? So only the syllabus is linear algebra, calculus, and probability and stats. Okay, these three topics are there. So if you're going to attend my session, so you can directly get into AI. Okay. And nowadays everybody knows that AI is, everywhere, right? It is one of the hot topic. Though I am from electronics background, so I always encourage everybody to go for electronics, like in VLSI. But if you happen to be interested in mathematics, so you guys can go for AI and machine learning. Okay, and you can grab a great packages, right? So this is just wanted to discuss. So let us come to the system of linear equation, right? We will start with the objective here, the objective of linear algebra, objective of LA. Okay, so the very first objective is nothing but the central problem of linear algebra is to solve, okay, to solve system of linear equation. So I think everybody might have solved equations in their life. Okay, if I start with the single variable, one linear equation. Okay, single variable equation. Okay, so we can start with the single variable equation. Okay, I mean one equation and one unknown. Okay, one equation and one unknown. That will not be known as system of linear equation. That will be just a linear equation. Okay, and why we call it linear equation, that everybody know also. The power, the degree of x, the degree of variable, right? So to solve the system of linear equation, we go for linear algebra. Okay, system of linear equation, it means that there will be many equations. We are talking about m equations. Okay, and okay, m equations. Let me write here, otherwise, m equations and n unknowns, right? To understand, we will start from the very basic here, right? So if I ask you, okay, just I'm going to take one equation and one unknown. Unknown means one variable, right? So suppose I take you through like x plus 5 equal to 0, right? Simple equation from your class 8th, x plus 5 equal to 0, right? So how many equations are there, guys? Can somebody tell me how many equations are there? um, One equation and one variable, one unknown, right? So if there is a number of equations equal to number of variable, okay, so this is a balanced system. Okay, life is balanced here. Okay, one equation, one unknown, right? So you can simply solve this equation. Do you need matrix to solve this equation? You don't need matrix to solve this equation. Yes, it is very simple. What is the solution of this equation? Can somebody tell me? The solution of this equation is nothing but x equal to minus 5. Simple. And this is unique solution, right? This is going to be unique solution. Okay. The value of x is only minus 5. And if you plug back this value to this equation, so it will satisfy this. Okay. Minus 5 plus 5 is going to be 0. So if number of equations equal to number of variable, or you can say number of unknown, okay, so that is the balanced system. Okay, the system is balanced. Okay, if the system is balanced, so you will always get, okay, if the system is balanced, so you can get unique solution, right? Unique solution. Okay, now let us take one equation and two variable. Okay, so just I'm going to take one equation like x plus y equal to 5. So how many equations are there, guys? Tell me here. Two equations are there. Sorry, one equation is there and two variables are there, two unknowns, right? One equation, two unknown. Okay, one equation and two unknown. Understand? So can we get the unique solution in this case? Unique solution means what? Finding the value of x and y, and that should be only one, right? One solution should be there, that is known as unique solution. One solution, right? So can somebody confirm me, can we get unique solution from this? Is it a balanced system? Your life is not balanced here, okay? You see here one equation and two unknown. So can somebody tell me what are the possible value of x and y here? You can take either 1 and 4, right? You can take 1 and 4, 4 and 1, 2 and 3, 3 and 2. Okay. 0 and 5, 5 and 0. Yeah, you can take these values, right? So there are many values, you can say. There are many values, okay? And if you happen to plot this, right, x plus y equal to 5. So this is basically the straight line equation, right? This is straight line equation. So you can say x plus y equal to 5, which is a straight line. You can plot also this, simple. Simple, start plotting also. This is y, this is x. Take y equal to 0. So x equal to 5. So this is a point where 5 and 0. And this is a point where 0 and 5. So you can join them, right? Simple. Okay, plotting a straight line equation is very simple. Okay. So on this line there are many value of x and y which is going to satisfy this equation, right? X plus y equal to 5. Okay. So we can't get unique solution. Remember, in this case we can't get unique solution. Okay. Because see, one equation and two unknown. We can't get unique solution. That you have to keep in mind. Now we will go for pair of equations. Okay. So pair of equation means what? Pair of equation. Let's take pair of equation. Okay. Pair of equation means two equations. Okay. So we are starting from very basics. Okay. Pair of equations. So we can take two equations like consider pair of system of linear equation of the two variable, right? So we can take two equations like 2x minus y equal to 0, okay, and minus x plus 2y equal to 3. These are the two equations, right? These are the two equations and two unknown. So if I ask you, can you solve these two equations? So can you suggest me what are the method you know to solve system of linear equation of if there are two equations and two unknowns, right? Can you suggest me some of the methods, yes, which you have studied, जो आप पढ़ चुके हो अपने क्लास में? How can you solve these two equations to determine the solution of x and y? I mean x and y, the value of x and y. So there are various methods. Like the first is elimination method. Okay, the very first is elimination method, right? And the second is substitution method. Okay, so first is the line number 1, you can say, and this is the line number 2. Okay, these are two lines. Okay, these are two lines, guys. Okay, so you can also plot these two lines. Okay, so remember, I will be going for elimination. And what is the meaning of elimination? Yes, Shivam. What is the meaning of elimination? Elimination means deleting one variable and finding other, and then once you got the new the value of the variable, okay, what you are looking for, you can plug back to the equation and you can get the value. Okay, but I'm not going to do here anything. The moment you see 2x minus y equal to 0 and minus x plus 2y equal to 3, right? So you can immediately write this in the form of a rectangular array of number. You see here, I'm going to collect the coefficient of this. Okay, what is the coefficient of first term? This is the equation, you can say polynomial equation. there are two terms. One term is this, one term is this, right? So the coefficient of this x is 2. So you just write 2 here. The coefficient of y is minus 1. The coefficient of minus x is minus 1. The coefficient of this guy is 2. Okay. Now write here the unknowns, which is x and y. And then you write the right hand side also, that is 0 and 3. Okay. So we are able to, the moment you will get pair of equations or 3 equations, 4 equation, 10 equation, n number of equation, right? So you should be able to write in this format, and this is known as A. We always represent, okay, this is A, and we call this as X, and this is the right hand side, which is B. Okay. Yes, Saurabh, you might be familiar with many methods, right? But the powerful method will be here to solve the system of linear equation. Okay, is the elimination only, right? Okay, we will going for elimination. Okay, and there are many methods also, like Cramer rules will be there, LU decomposition will be there, right? Elimination is one of the powerful one, right? So you see here the matrix A, we call this as a matrix A. Okay, the matrix A, okay, this is just a matrix. Okay, matrix is nothing but the rectangular array of number. You see here we have just put the number. Okay, we have got this number from the coefficient of the equations, right? And the coefficients, you see here, coefficient of these terms, right? So this is also known as coefficient matrix. You can say this is the coefficient matrix. Okay. So what we are doing here is, and this x will be known as, keep in mind from now onwards, this x will be known as the column vector. इसको क्या बोलेंगे? Column vector. Okay, column vector. Why we are calling it vector? It has got two component, x and y. X is one component, y is another component. This is also a column vector, guys. Okay, this is also a vector, right? Column vector. Okay, so what we are doing here is we are multiplying matrix. We are multiplying matrix and the column vector, and you are getting the column vector. Okay. So we have got pair of equations. You can also tell me the value of x and y quickly. Yeah, just write your the value of x and y on the comment box quickly. Yes. So the moment you will get this kind of equation, you have to write in this format, that a times x equal to b. So we will call this as ax equal to b. Okay, ax equal to b. This is also known as system of linear equation. System of linear equation, right? Okay. So you can say that this is the shorthand representation. Shorthand representation of system of linear equation. Ax equal to b. Okay. Ax equal to b. Now you see here, guys, what we are doing here is we are multiplying matrix into vector, and we are getting what? Vector. One of the coolest operation, you see. Based on this concept, this year in electrical engineering one question was there. The matrix into vector, you are getting the vector itself. Yes, Saurabh, 1 and 2. Have you ever made observation like this? The matrix into vector, you are getting vector. Why we are calling it vector? Because there are two components. Okay. Okay. You will understand that why we are calling it column vector as well, right? So this is a column vector. If I see this matrix, okay, alone, okay. So you see here, this will be the column number 1. This is column number 2, and this is row number 1. This is row number 2. Okay. So this vector, this matrix has got 2 rows and 2 columns. Why? 2 rows and 2 columns, right? So if I talk about order of the matrix, so order of the matrix is 2 by 2. Okay. Can somebody tell me why there is 2 rows and why there are 2 columns? Anybody? If there are 2 rows means what? What does this tell? 2 rows means that you have got 2 equations, remember. Okay, 2 rows. Number of rows means, yes, yeah, Devans. AU equal to V, yes. Okay, matrix into vector, you will get vector, right? See, 2 rows, number of rows means number of equation. Always keep in mind. 2 rows means 2 equation you have got. And there are 2 columns. What is the meaning of 2 columns? 2 columns means 2 unknown. Okay. Okay. So remember, if I give you one equation, so how many rows will be there, guys? There will be only one row. And if there are 2 variables, means how many column will be there? 2 columns. How simple is this, right? Only you have to make observation. A beautiful observation can help you understand anything. ठीक है? So ये बहुत ही important चीजें हैं. These are very important things which nobody discuss. I will be talking about matrix algebra. I will tell you the type of the matrix, what is the square matrix, what is the meaning of identity matrix, what is diagonal matrix, everything I'm gonna talk. But you should understand the objective of linear algebra first. ठीक है? I hope you might be enjoying the session from a different way, right? Because this is a completely new way of understanding linear algebra, right? Okay. So 2 rows and 2 equations, 2 columns and 2 unknowns, right? So number of column, you can generalize now, okay? In general. Number of rows, hashtag means number of rows is equal to number of equations. Number of columns equal to number of unknowns. Yes. Okay. Please keep in mind these points. Now coming to going forward, right? Going forward, we will be talking about the how to graph these equations. Everybody knows how to graph straight line equations, right? So if you are going to plot a straight line equation, that plot will be known as row picture. इसको क्या बोलेंगे? Row picture. Okay. Plotting of the equations, okay, on x by plane. Okay, here plotting of equation on x by plane will be giving you the row picture. Okay, the row picture means you are just representing row on a xy plane. Okay, row on xy plane. Somebody will ask you, can you plot the row on xy planes? You will say, sir, how can we plot? My sir has told me only what? Sir, this is order the matrix. Okay, how to add two matrix, how to multiply two matrix. Nobody has told me that how to picture, how to represent on xy plane. Okay, but that is not going to be new for you, right? If there are two equations and two unknown I'm talking about, right? There will be three equations and three unknown. You will get plane. And four equation, four unknown. It will be very hard to represent in fact, right? ठीक है, तो अभी टू इक्वेशन टू अननोन के बारे में जानो. So basically matrices is just a set of number which then multiply by some variable gives you a vector. No, not variable. By some value. No, you have to multiply with some vector, okay? Yeah, there will be variable inside the vector components. Okay. And matrices are the set of numbers, yes, the rectangular array of number. Okay, I will give you the example as well. Okay. And that is also matrices only, that is also matrix only. You see here, you are taking one matrix, you are multiplying with the matrix, you are getting matrix only, right? But in terms of vector concept, okay, that you have to study linear algebra, because vector space and the subspace will be the heart of linear algebra. Okay, you can also mention here, this is the heart of linear algebra, guys. This is a heart of LA. Okay, just like CPU is the heart of computer, so real story will start from vector space. Okay. So plotting of the equation on x biplane, that is row picture. You can plot the row picture, right? So we have got 2x, very first is 2x. Let me take this equation here from here, right? Just I'm gonna take this equation and I'm gonna paste over there. ठीक है, ये देखो. अब इस this equation we have to plot it. So I think anybody can tell me the plot, right? So just I'm gonna plot the very first line. Okay, the very first line on xy plane. In class 10th, the very first chapter, I mean, from third chapter in NCRT, if I talk about, right? So in my days, it was first chapter, but in NCRT nowadays, third chapter, right? So 2x minus y equal to 0, anybody can plot. This is a straight line equation which is passing through origin, right? Because you see right hand side is 0, so y equal to 2x, okay? So it is simple, it is just passing through origin and nothing else, right? So you can pass through origin. This is the straight line equation, okay? And this is the row number 1 we will call. Row number 1 we have plotted here. If you are plotting line, it means you are plotting row. And you can find also these coordinates. If you take y equal to 0, on x-axis y equal to 0 always, on y-axis x equal to 0. So y equal to 0, so x is minus 3. Okay. So this is a point somewhere minus 3 and 0, and you can take this point, any point here, like x equal to 0 means y equal to 3 by 2. So this is a point 0 and 3 by 2. So you can join now. Okay, so you just take this guy up, right, so that you can let me take this so that it will be like this. Okay, you have to draw the straight line. Okay, this is a point minus 3 and 0. So this is a point where they are intersecting each other. This is a point where they are intersecting each other. Okay, this is a point where they are intersecting each other. Okay guys, I believe this is fine for you. So if they are intersecting each other means what you will get? This is row number 2. If two lines intersect at one point, it means you will get unique solution. Okay, so this is the solution point, you can say. This is a solution point where two equations are intersecting, right? So graphically, if you are able to plot, graph, if they will ask you in the interview, can you plot the row picture on the xy plane? Okay, or xyz plane, right? So you can so simply, right? You have two equations, you know how to plot the equations, okay, by finding two points, okay, this point and this point, right? Okay, so this is known as row picture, guys, and this is how we plot the row on xy plane. And now we will talk about column picture, and this is very interesting. Column picture, okay, and column picture is interesting, right? And column picture is basically when we plot the column picture, we will say that this is the vectorial representation of system of linear equations, right? So this is the vector interpretation I'm talking about. Vector interpretation. Okay, everybody knows that vector has magnitude and that direction as well, right? So vector has magnitude as well as direction. Here, in case of matrices, in case of vectors, whatever column vector we are considering, right? Now keep in mind, row means row vector, column means column vector. Okay. So you see here we are going to take the same equation again. You see these two equations we have taken. Now I'm going to write these these coefficient in some different manner. You see here this is we are collecting 2 and minus 1, and we are writing x here. X times, just consider the coefficient of x only separately, plus by times of the coefficient of by, that is minus 1 and 2, and this is 0 and 3. Okay, so how many columns are there? One column, this is column number 1, this is column number 2, and this is column, okay, again one column, the resultant column you can say. So you know that if you take any in terms of just scalar constant you take, right? If you take a multiply with x1, right? If you take b multiply with x2, so okay, what is the meaning of this? Can somebody tell me what is this? Okay, in signal system you might have seen, if you have got one system, okay, just I'm taking x1, you are getting output by 1, x2 you are getting by output by 2, right? Multiply by some scalar constant, so a times x1 plus b times x2, so you will get a times y1 plus b times y2. What is this? This is basically the linear combination. Okay, what is this? Linear combination. Okay, we are multiplying by the scalar and we are summing them up. Okay, so here we will say this is basically the linear combination of column vector. You can write this. Okay, linear combination of column vector. Okay, if you want to write linear combination, see, we are able to get this right hand side b vector with the help of linear combination of column 1 and column 2. Okay, column 1 and column 2, right? So you can also say that we are able to generate vector b. Okay, this is a vector b here, right? We are able to generate vector v by taking the linear combination of the vector. First vector, column vector means pehla vector, second vector. Okay, so this is also known as spanning. Okay, spanning, you are generating new vector here, right? So if you know the x and y value, okay, you know x and y value, right? You can simply find out from here. Okay, so if x is 1, 2, and if y is 2, right? So 2 minus 2 will be 0 here, right? And minus 2 plus, sorry, minus 1 plus 4, that is 3, yes. So from here also you can find x equal to 1 and y equal to 2 directly. Yes, directly. If you are able to write in this format, like linear combination of column vector, okay. So we always read this as linear combination of column vector. Okay, linear combination of column vector. Understood everybody? So whenever two equations will be there, again let me explain, this is very important concept guys. This will form a basis, okay? And from next class I will start linear the matrix algebra and all, right? Today's class is just to understand my way of teaching, right? So if you want to write in terms of linear combination of vector, okay, linear combination of vector is nothing but if you are going to write linear, taking the linear combination, it means you are generating some new vector as well. Okay? So any vector, suppose 0 and 3 is given, so can we get from these two vectors? Yes. So x times 2 and minus 1 plus y times minus 1 and 2. So if you take the linear combination of these two vectors, you can choose any value of x and y, but that should satisfy the right hand side, right? 0 and 3. Okay. So this is the column vector 1, this is the column vector 2, and this is the column vector itself, that is b vector. So from here we read this as linear combination of column 1 and column 2, or you can say column vectors, simple. Now the question is how to plot this on a xy plane. Okay, and you know how to add two vectors. Here what we are doing is we are adding two vectors because x and y are the constant. Okay, we can take as a constant, right? X equal to 1 and y equal to 2, right? Any value of x and y, right? They are variable though, but here if you take x equal to 1 and y equal to 2 and add two vectors, then so how to add two vectors? We know there are various method. Okay, addition of there are different laws of addition, right? Like triangular law of addition, parallelogram of law of addition, right? So we will first of all we will show you on xy plane, right? So let me show you on xy plane. You see here, so this is xy plane, this is y axis and this is x axis. Okay, any vector is there which has got component 1. Okay, keep in mind this vector will be having the component 1 and the component 2 here, because this is two-dimensional vector. Okay, two-dimensional vector, it can have 3 component, can have 4 component. Okay, but here one component is 2 and one component is -1. You know, you just go 2 here, 1 2 on x-axis, -1 on y-axis. So this is -1. So you can say this is a point. Okay, this is a point. So 2 -1 you can write like this also, just like coordinate. Okay, 2 -1, but it is not a column vector. The column vector is 2 -1. Okay, but this is simple coordinate. Okay, so we can represent this as 2 -1, or you should not show like this, you can write like this, 2 -1. Okay, and simply how to represent vector, everybody knows how to represent vector, guys, with an arrow. So यहाँ पर arrow लगा दो. Okay, this is an arrow. Okay, now this is first column. Okay, we call it, this is column number 1. Now coming to column number 2, -1 on x-axis, go to -1. See, this is -1, 2. So you have to go 1 2. This is a point. Okay, this is a point. Okay, we can okay, this is the point. Okay, this is -1 and 2. Okay, this is -1 and 2. Okay, so these are the column vector. So can we add these two vectors? Yes, we can add these two vectors. Okay, so we just take x equal to 1 and y equal to 2. Okay, so just multiply with this vector 2 and -1 1. So nothing is going to change. You know, if you are multiplying by 1, so your vector will be same here. This vector will be same. But if you're going to multiply this vector by 2, right? You can multiply by 2 here. So it will become this vector will become what? 2 times of -1 and 2, right? What is the meaning of this? What is this mean? What is the meaning of this? If you are going to multiply by some scalar constants, your vector length will increase, right? So this vector is here. You can say 2 times of -1 and 2, right? Double of that. And one more thing we know, that if you translate vectors on the plane, okay, suppose this vector is there. If you okay, let me show here. Everybody knows that. Suppose this is a vector, right? If you in parallel, if you translate this like this, nothing is going to change. Yes, nothing will be changing. Okay. So after all, we have to add these two vectors. One vector is this, one vector is this. So what you will do? You have to take this tail of the vector, put here. So you can add these two vectors then. Yes, like this. So this will be the resultant vector, that is 0 and 3. Okay, this is how we add two vectors. Okay, understood? So you see here we are adding these two vectors. One vector is this. Suppose you can say let me take here, suppose one vector is this A vector and this is V vector. So if you want to add A and B, so what you will do, you will take this B here and now add it, right? So this is a new vector C will be equal to A vector plus B vector, and we call this as triangular law of addition. Everybody is familiar with this concept? Please confirm once. How to add two vectors? Okay. So this is how we can. So why we are getting the next vector 0 and 3? Because we are getting what? This is these two equations are showing the unique solution, right? Okay. If you will not get any solution, then you will not get resultant vector. So this is a resultant vector also. Resultant vector. And if you want to understand, I can take one more example, right? So okay, I will be taking one more example, guys, so that you guys can understand this concept better, right? So let me take one more example. Just I'm going to take one example, right? So that you will understand. So please note down these points for the moment, okay? So this is how we show, okay, the linear combination of column vector and column 1 and column 2, and this is also known as a column picture. Okay, so if you are representing your matrix in the form of row picture and column picture, that is known as geometry of linear algebra. Geometry of linear algebra is nothing but what? The row picture and the column picture. Okay, and row picture and column pictures are nothing but what? Row picture means just plotting the equations of a line, straight line on a xy plane, right? Simple, if there are two equations and two unknowns. Okay, I think now it is clear for everyone, yeah. And column picture is nothing but just put vectors on xy, how to add two vectors, how to subtract, how to multiply by the scalar, right? So these are the operations we can perform on the vector, that everybody should know. Okay, if I give you any number, so you should be able to talk about right? So we'll take one more example to understand, to illustrate the same concept, right? So let me take one very good example here. Suppose we are taking again two equations like x plus 2y equal to 4 and x minus y equal to 1. Okay, these are the two equations. Perfect. If we have got two equations, then we can write them immediately in terms of ax equal to b, or we can write them in terms of linear combination of column vectors. So x times 1 1 plus y times 2 minus 1. This should give you the next resultant. Okay, there is a column 1, this is column 2, and this is next column, resultant column, you can say. Now we are plotting this on xy plane. So 1 1 will be here, 1 1, this is 1 1, right? 1 1, 2 minus 1, 2 minus 1 will be here, so 2 is like this and minus 1 here, right? This is 2 minus 1. Now guys, tell me what is the value of x and y. Okay, so here x equal to 2 and y equal to 1, right? Okay, if you take x equal to 2 here and y equal to 1, so this will satisfy. Okay, so what is the meaning of x equal to 2? You are multiplying by constant with this vector. So if you are multiplying with any, suppose this vector is 2, and if you are multiplying with 2, so it becomes 4. Okay, I am talking about magnitude, right? So the length of the vector is going to be same. Length of the vector will be same. Only what will differ is the, what will be changing? Tell me. The magnitude will change. The length of a vector is going to be changing, right? Okay. So here what you have to do, you can, this is a vector here, that is 1 1. Now we are multiplying by 2. Okay. So this vector will become like this. So this is 2 times of 1 1. Okay. Now you can take this guy here. This vector we are translating to this, so that we can add these two vectors. Now the resultant is this. What is this? This is 4 and 1. Okay, you can say this is 4 and 1, right? So I believe now this is a column picture, and everybody understood how to draw the column picture on a XY plane. Yes? Everybody understood? Please, out of all concurrent viewers, right? Please confirm in the chat box if you have understood this, right? Because I will be taking the session further, okay, from the next lecture number 2 only, okay. For today, this will be the enough as an introduction, right? And if you have any concept doubt, you guys can ask now. Yes, quickly. So everybody understood this entire session? Okay. Please write on a chat box, and yes. So what I'm planning here is I will be taking session tomorrow as well, right? And yes. Yes, Devans, yes. The very first example is, yeah. But at least you understood linear combination of column vector. That is just a starting of your life that you can understand. Okay. Because everybody knows what is the meaning of linear combination, right? But how to apply? You know it. One of my friend was there, he was the topper of GATE 2014. He said that Dheeraj, when he got first rank, I messaged him on LinkedIn, right? He says that Dheeraj, many people know the concept, but they are not able to apply it. Okay, here people don't know the concept. Okay, we don't know the concept. Okay, we know the matrix as just 2 by 2 matrix, 3 by 3 matrix. Okay, we are just okay. Now you will feel it, why we are applying elimination, what is the need of elimination. So next session will be on elimination. Okay, they are the basic practices we will do on matrices, right? It will be couple of hours. Okay, so I mean not couple of hours we can say, but 1.3, 1.5 maximum, right? So that you guys can also rewatch. So these session will be available on the unlisted link, so you guys can watch it, right? So thank you so much for today. If you have any doubt, okay, you can ask. Okay, related to today's session, right? So from the next season, we will continue, and we will take some PYQ, latest PYQ of 2023. Okay, and let me tell you one more thing, guys. All questions was from my session, right? This year in 2023, and next year also this will be there, right? So if you are crazy about math, if you want to keep your hand dirty with the math, you should join the session by 7:30 every day. Okay, you will definitely enjoy it, and each and every technical subject will be taken care of if you are good in math, that I can assure you. Okay, so linear algebra, calculus, and probability, if you are good in these three topics, your life is gonna be very beautiful, right? Okay, so any other doubt, guys, related to this session? Please do ask, okay, that I am ready. And if somebody has any kind of doubt, like personal doubt, you guys can contact me anytime. Okay, that why I'm conducting this session on this platform, because you guys can rewatch it any number of times, and you can also share this session with your friends, right? So thank you so much. We'll meet. Okay, you guys can share, but don't share on different telegrams, but you can share with your friends if they want to watch, right? Thank you. if you don't have any doubt. Ankit, everything is clear. Shivam, Saurav, Isika, okay. Devans, Rajiv, Ganishka, perfect. So we'll meet. Thank you so much, guys, for today. Again, we'll meet and we'll understand LA completely. Thank you so much.